Hi, and welcome to our penultimate lecture. This is going to be on storing data and data structure. So, we've talked about how to store data in a single piece of data, though, in a variable. But what if we want to store several things at once other than just characters in a string? We're going to be working with a lot of data over the next 6 weeks. We need to store it somehow. This is where data structures come in. The primary data structure of Python is a list, but there are a lot of others included, such as arrays, which can be included with NumPy. They're pretty comparable. Uh, Fair warning, data structures in most computer science curriculums is an entire class. So this is going to be a pretty cursory look at what they are, and we're not going to dive in as deep as the topic often demands, but hopefully enough to give you guys a good idea of what we're doing. So let's talk about lists for a bit. Lists are a collection of items, and the naming convention for lists is the same as is for variables. Lists can contain any data type, and they are denoted with a square bracket. To declare a list of strings, we can do something along the lines of cities is equal to Laramie, Cheyenne, Casper, Gillette. This would give us a list with 4 elements. So let's run that code block so I don't embarrass myself later down the line. We have elements in a list. How do we utilize them? So how I like to do it and how I think it's best described is each element in a list has its own index or address. Think of lists as being a street with houses on it, and each house has its own address. So Laramie has its own address, Cheyenne has its own address. This is where and why we start counting at 0, as I mentioned in an earlier lecture. The index value of a list starts at 0. So Laramie's address, where Laramie's is 0. It's not 1. We have 4 elements in our list right now, but the index position 4 does not exist. You will get an error. Um, the indices range from 0 to n, where n is the number of elements in the list minus 1. So 0, 1, 2, 3 is all we have indice wise. You can access individual elements based on their index. So cities of 0 will give us Laramie. Let's, for the sake of argument, what does it do when we put in 4? List index out of range, exactly as we knew it would be. Just because we have 0, 1, 2, and 3 as the index values. But if we feed in 0, we're using the square brackets because it's a list, we get Laramie back out. You can overwrite values at an index. So if we're going to do excuse me, I'm recording these lectures back to back, so my voice is wearing thin a bit. Cities at index 3, we're going to overwrite Gillette and we're going to make it Jackson Hole. So we can do that and we can see cities at index 3 is now Jackson Hole. We print it out just for verification, and Laramie, Cheyenne, Casper, Jackson Hole. Got rid of Gillette. Overriding is good, but we can also add or remove elements. What happens when you initialize a list with a subset of elements, but you need to add more elements? You can initialize an empty list by doing my list is equal to square brackets. That's just an empty list. There's nothing contained in there. Okay? So you have an empty list. What if we want to add to it? This can be done by calling it. Well, this can be done in a couple ways, but we're going to talk about the append function first. So let's say we want to append Sheridan on. Notice that it's using the dot operator. So append is a member function of lists. Function calls always have the parentheses following them. You can't just do dot append and no parentheses. And since append takes a parameter, you have to pass the parameter. Yeah. You guys have probably watched the functions lecture already, so you've gotten the primer on functions. Append always adds the element being appended to the end of the list. So we can do append Sheridan, print cities, Laramie, Cheyenne, Casper, Jackson Hole, Sheridan. But what if we want to put What if we want our lecture to be correct? Wouldn't that be grand? Sorry about this. Just getting it a little easier to read and for when you guys go and download this. It'll be fixed when you download it already. But so calling insert, we can add an element to anywhere in the list. Insert takes two parameters, the index to insert at and the element to be inserted. So let's say cities.insert at position 1, so the position after Laramie. We're going to insert Pinedale. So our list previously was Laramie, Cheyenne, Casper, Jackson Hole, Sheridan. And now we're going to insert Pinedale in, and Laramie, Pinedale, Cheyenne, Casper, Jackson Hole, Sheridan. Yeah, so that's the two main ways we're going to add elements to a list. But what if we want to remove elements? Get rid of them. This can also be done in just a few different ways. You can use the delete keyword to delete an element at a specific index. So delete cities at position 3 will give us a list removing, having removed Casper. So 0, 1, 2, 3, Casper's got to be gone. So we run that code and Casper has in fact been removed. Alternatively, we can use the pop function to not only remove an element, but get its value back. Pop can be used either with a parameter or without a parameter. Without the parameter, it just removes the final element in your list. So if we call it without a parameter, we're going to remove Jackson Hole. We're going to remove Sheridan, excuse me. Laramie, Pinedale, Cheyenne, Jackson Hole. Sheridan was at the end of our list. Now it's gone. Alternatively, we can do pop and supply an index value to remove an element from our list. So if we want to get rid of Cheyenne, it's cities.pop at position 2, again 0, 1, 2, 3, 2 is Cheyenne. We do that, print, and we just have Laramie, Pinedale, Jackson Hole left. As I mentioned earlier, we can get the value we're removing back. So if we do cities.pop and assign that to city, we can print out that city and print out our cities. So we're removing Jackson Hole and assigning it to the variable city. We're printing out that variable, and then we're just printing our list again for verification. Only 2 elements left. The final way we're going to look at removing elements is the remove function. Funny how that works out. You call it and you pass it a specific value that you want to remove from the list. So, nope. There we go. So cities.remove Pinedale will leave the list with only Laramie. Man, I did a bad job at copying these in from the markdown. Okay, cities.remove Pinedale, print cities, Laramie. Great. There's a lot of other things we can do with lists, though. So, sorting a list. Or you guys might remember from the logic control lecture, we used a for each loop to go through each element in a list. So what happens when you have a list with data in a random order, but you need it to be ordered? That's when sorting comes in. In a lot of cases, the built-in .sort function, again, part of the lists class, can do it for you. So our list from before is pretty empty at this point. It's only Laramie left. There's not much to sort there. So let's make a new one with integer values. 16, 4, 23, 8, 42, 15. So these numbers are vitally important, but only when in the correct order. If you get this joke, I'm glad someone got it. So we can call nums.sort on our list, and it will kindly sort our list, giving us 4, 8, 15, 16, 23, 42. And we'll show that now. So we can declare our list, nums, and then print it out, 16, 4, 23, 8, 42, 15. It feels weird saying those out of order. And then we can go ahead, sort, and print. So one thing to note, nums.sort changes our list, and it changes and saves the list to be the same thing. So nums now is in its sorted state. It doesn't exist, quote unquote, anymore in its unsorted state. we can also temporarily sort a list. So we're calling the sorted function. So this is not called with the dot operator. We instead pass the list as a parameter, and since it's not operating on the list itself, I'm not going to get into the whole semantics of this. But this can return a sorted list to get a sorted copy of the list. So we have nums, again, in the unsorted order, and we can go ahead, print out the sorted nums. And since the function call of sorted nums returns the sorted list, we can print that. So we have nums printed out sorted first, but then we can also print it just nums by itself without doing anything else, again, to see that it remained in its unsorted state. Finally, well, not finally, the last two things we're going to talk about are reversing the order and getting the length of a list. So these are pretty self-explanatory from the headlines, but we can reverse the order of a list. So counting up is lame if you have your sorted list. What if you want to count down? So rather than 4, 8, 15, 16, 23, 42, it would be 42, 23, 16, 15, 8, 4. We're not doing this on the sorted list, but you know what? Here, just to show, nums dot sort. Okay. Sorts it, puts it in the reverse order. Finally, and this is very important for when we're looping through things, calling the length function len just returns the length of the list. So we have 6 elements in our list according to the length function, and 1, 2, 3, 4, 5, 6. We have 6 elements in there according to my math, which, isn't always right, but hopefully I'm able to count to 6. So yeah, that's our lecture on our quick primer on storing data. Excuse me. I'll see you guys next time for the final lecture.